Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. The AWS Certified Cloud Practitioner exam, currently referred to as CLF-C02, validates foundational, high-level understanding of AWS cloud, services, and terminology. In this video, we will be exploring 10 sample questions for this exam. The goal of this exercise is to review each question before exploring and eliminating incorrect answers, resulting in the correct answer being revealed. This is an essential technique for mastering AWS exam questions. Let's get started. A company has migrated its workloads to AWS. The company wants to adopt AWS at scale and operate more efficiently and securely. Which AWS service or framework should the company use for operational support? Let us identify and interpret key phrases in the question that will help with answering it. The scenario describes a company that has already migrated its workloads to AWS and is now looking to adopt AWS at scale while focusing on efficiency and security in operations. The phrase "at scale" is particularly important. It signals the need for structured guidance for ongoing operations, not just initial adoption. The company is not merely seeking technical support or one-off services. Rather, it is looking for a framework or methodology to continuously improve operational excellence and security. This positions the question in the realm of architectural best practices, rather than reactive support or managed services. Option A, AWS support. AWS support provides access to technical experts and troubleshooting assistance across various support plans. While useful for incident response and service-related questions, it does not offer a structured, scalable approach for operational excellence or ongoing architectural improvements. Incorrect, because AWS support helps with issue resolution but does not provide a framework for scaling operations securely and efficiently. Option B, AWS Cloud Adoption Framework, AWS CAF. The AWS CAF is designed to guide organizations in their initial cloud adoption journey, addressing organizational change, governance, and readiness. It's useful at the start of cloud transformation. However, in this case, the workloads have already been migrated, and the focus is now on operating at scale, which AWS CAF does not directly support. Incorrect, because AWS CAF is best suited for planning cloud adoption, not for ongoing operations at scale. Option C, AWS Managed Services, AMS. AMS provides operational support by managing AWS infrastructure on behalf of the customer. While it does improve efficiency and security, it is a fully managed offering, meaning the customer hands over a significant portion of the operational responsibilities to AWS. The question asks for something the company should use to operate better, not a service that does it for them. Incorrect, because AMS is a managed service, not a framework for improving customer-led operations. Option D, AWS Well-Architected Framework. The AWS Well-Architected Framework is designed to help customers review and improve their workloads based on 5 pillars: operational excellence, security, reliability, performance efficiency, and cost optimization. It is explicitly created to support customers operating at scale by offering best practices, design principles, and architectural guidance. This aligns directly with the company's goal of improving operations efficiently and securely after migration. Correct, because the well-architected framework is the ideal solution for optimizing workloads at scale, with a focus on operational excellence and security. A company wants a time series database service that makes it easier to store and analyze trillions of events each day. Which AWS service will meet this requirement? Let us identify and interpret key phrases in the question that will help with answering it. The focus here is on a time series database service that can store and analyze trillions of events each day. This means the solution must be designed for timestamped data, must scale automatically, and should be optimized for analytics over temporal data patterns, common in use cases like IoT metrics, application logs, or sensor data. The key signal in the question is the explicit mention of time series database, which is critical in eliminating options that aren't purpose-built for that pattern. Option A, Amazon Neptune. Amazon Neptune is a graph database service, primarily used for storing and querying highly connected data using graph models like RDF or property graphs. It's optimized for relationships between entities rather than time series data. Incorrect, because Amazon Neptune is designed for graph data, not time series workloads. Option C, Amazon Forecast. Amazon Forecast is a machine learning-based service for generating future predictions based on historical time series data. It is not a database and is unsuitable for ingesting and managing real-time streams of trillions of events. Incorrect, because Amazon Forecast is for predictive analytics, not for storing or analyzing high-volume time series event data. Option D, Amazon Document DB with MongoDB compatibility. Amazon Document DB is a document database service intended for semi-structured data stored as JSON. It is optimized for flexible schemas and document-style queries, but is not tailored for time series workloads or analytical efficiency at massive scale. Incorrect, because Amazon Document DB supports document data models, not time series storage and analytics. Option B, Amazon TimeStream. Amazon TimeStream is purpose-built for time series data. It is a fully managed serverless database that automatically scales to handle trillions of time-stamped events daily. It supports built-in analytics functions, handles data lifecycle efficiently, and integrates well with visualization and analytics tools, making it ideal for the scenario described. Correct, because Amazon TimeStream is specifically designed for high-volume time series data and analysis, making it the best fit. Which encryption types can be used to protect objects at rest in Amazon S3? Choose 2. Let us identify and interpret key phrases in the question that will help with answering it. The question is specifically about encryption types that protect objects at rest in Amazon S3. This clearly refers to how data is encrypted when stored in S3, as opposed to while it's being transferred. The important distinction here is between encryption at rest and encryption in transit. Only technologies that deal with storage-level encryption should be considered correct. The wording Amazon S3 further limits the scope to AWS native or compatible encryption methods that integrate with the S3 service. Option C, TLS, Transport Layer Security. TLS is used to encrypt data in transit, such as when it's being uploaded to or downloaded from S3. It ensures secure communication but has no role in encrypting data at rest in S3. Incorrect, because TLS is for encryption in transit, not at rest. Option D, SSL, Secure Sockets Layer. Like TLS, SSL is a protocol for encrypting data in transit. It's outdated and largely replaced by TLS in modern systems, but either way, it does not encrypt stored data in S3. Incorrect, because SSL provides in-transit encryption, not at-rest protection. Option E, Transparent Data Encryption, TDE. TDE is an encryption method commonly used in database systems like Oracle and SQL Server to encrypt data files at the storage level. AWS S3 does not use TDE for object encryption. Incorrect, because TDE is used for databases, not supported for S3 object encryption. Option A, Server-side encryption with S3 managed encryption keys, SSE S3. This is a valid and commonly used method for encrypting S3 objects at rest. With SSE S3, Amazon S3 manages the keys and automatically encrypts each object using 256-bit advanced encryption standard. Correct, because SSE S3 enables automatic encryption at rest using S3 managed keys. Option B, Server-side encryption with KMS managed keys, SSE KMS. This method uses AWS Key Management Service to manage encryption keys. It offers additional features like audit trails and tighter access controls via IAM and KMS policies. Objects are encrypted at rest with keys managed in KMS. Correct, because SSE KMS encrypts objects at rest using customer or AWS managed KMS keys. A company has teams that have different job roles and responsibilities. The company's employees often change teams. The company needs to manage permissions for the employees so that the permissions are appropriate for the job responsibilities. Which IAM resource should the company use to meet this requirement with the least operational overhead? Let us identify and interpret key phrases in the question that will help with answering it. The company's scenario describes a dynamic workforce where employees frequently change teams. Each team has distinct job roles and responsibilities, and the organization needs to ensure that users have the correct permissions at all times based on their current team. The goal is to maintain proper access control with the least operational overhead, meaning minimal manual configuration and maintenance. Option B, IAM roles. IAM roles are designed primarily for temporary access, such as cross-account usage, federated user authentication, or service-to-service interactions. While roles can technically be used for users within the same account, managing roles and trust relationships introduces more complexity than simply assigning users to groups. Incorrect, as it is better suited for temporary or conditional access, not long-term role-based access within a company. Option C, IAM instance profiles. An IAM instance profile is used to attach an IAM role to an Amazon EC2 instance, so the instance can assume permissions and interact with other AWS services securely. This is useful for workloads, not users. Instance profiles that don't help with user-level access control, team transitions, or policy management for employees. Incorrect, as it is relevant to EC2 instances, not for managing access for human users across teams. Option D, IAM policies for individual users. Assigning permissions directly to users may offer precise control, but it leads to high operational overhead, especially in a dynamic environment. Every time a user changes roles, an administrator would have to manually remove and reassign policies, an error-prone and time-consuming process. It also makes tracking and auditing access more difficult, as policies are not centrally organized. Incorrect, as it is fine-grained but not scalable, leads to fragmented permission management. Option A, IAM user groups. IAM user groups are the most suitable mechanism in this scenario. Groups allow administrators to define permissions once and assign them to multiple users. IAM groups help enforce the principle of least privilege by making access dependent on group membership, which can be changed quickly and reliably. They also simplify auditing and troubleshooting by organizing users according to their functions. This makes IAM user groups the ideal choice when access must be aligned with job roles that change over time. Correct, because IAM user groups offer an efficient and scalable way to manage access by associating permissions with job functions. A company wants to migrate its database to a managed AWS service that is compatible with PostgreSQL. Which AWS services will meet these requirements? Choose two. Let us identify and interpret key phrases in the question that will help with answering it. This question centers on two key requirements. The company is looking to migrate a database, and the target should be a managed AWS service that is compatible with PostgreSQL. A managed service implies that AWS will handle operational tasks like patching, backups, and scaling. Compatibility with PostgreSQL means that the service should support PostgreSQL's data types, extensions, and SQL syntax to minimize migration effort. Therefore, the services selected must offer both operational simplicity and PostgreSQL compliance, ensuring a seamless transition from an existing environment. Option A, Amazon Athena. Amazon Athena is a serverless query service that analyzes data stored in Amazon S3 using standard SQL. However, Athena is not a database engine, and it does not support transactional operations or persistent data storage. Moreover, Athena is not compatible with PostgreSQL databases in terms of serving as a managed relational database platform. Incorrect, because it is not a database engine and not PostgreSQL compatible. Option C, Amazon EC2. Running PostgreSQL on Amazon EC2 is technically feasible, but it requires the customer to manage the entire stack: installation, configuration, scaling, patching, and backups. Since the question specifically asks for a managed AWS service, this option does not qualify. Incorrect in this context because it's not a managed service. Option D, Amazon DynamoDB. DynamoDB is a fully managed NoSQL key-value and document database. It does not support SQL-based relational queries or PostgreSQL-compatible features such as joins, stored procedures, or complex data types. It's designed for different workloads than a traditional relational database. Incorrect, because it is a NoSQL database, incompatible with PostgreSQL. Option B, Amazon RDS. Amazon Relational Database Service, RDS, is a fully managed service that supports multiple relational database engines, including PostgreSQL. It automates administrative tasks such as backups, patching, and failover. Choosing Amazon RDS with PostgreSQL as the engine allows the company to migrate its existing PostgreSQL workload with minimal code changes, benefiting from both managed infrastructure and feature compatibility. Correct, because it is a fully managed relational database service with direct PostgreSQL compatibility. Option E, Amazon Aurora. Amazon Aurora is a cloud-optimized relational database that is compatible with both MySQL and PostgreSQL. Aurora offers improved performance and scalability while remaining fully managed. Choosing the PostgreSQL-compatible edition of Aurora provides the same SQL support and features as native PostgreSQL, while benefiting from Aurora's high availability and performance advantages. Correct, because it is a fully managed, PostgreSQL-compatible, and performance-optimized option. A company is building an application that requires the ability to send, store, and receive messages between application components. The company has another requirement to process messages in first-in, FIFO order. Which AWS service should the company use? Let us identify and interpret key phrases in the question that will help with answering it. This question highlights two critical operational requirements: the need to send, store, and receive messages between application components, and the requirement that messages be processed in first-in, first-out, FIFO order. These phrases suggest an architecture based on message queuing, where decoupled components communicate asynchronously by passing messages. Ensuring FIFO message delivery adds an extra constraint that not all messaging or streaming services support. Therefore, the ideal service must enable message persistence, decoupling, and strict message ordering. Option A, AWS Step Functions. AWS Step Functions is a serverless orchestration service that sequences AWS Lambda functions and other services into workflows. While it can coordinate tasks and manage execution order, it is not a messaging service designed for sending and receiving messages between components. It does not provide FIFO messaging queues or durable message storage across decoupled systems. Incorrect, because it is not a messaging service, lacks support for FIFO message queuing. Option B, Amazon Simple Notification Service, Amazon SNS. Amazon SNS is a fully managed pub/sub messaging service used for sending messages to multiple subscribers at once. SNS is excellent for fan-out messaging patterns and mobile push notifications. However, it does not support message ordering, nor is it designed for FIFO processing or decoupled asynchronous message queuing. Incorrect, because it is a pub/sub model with no FIFO message ordering guarantees. Option C, Amazon Kinesis Data Streams. Amazon Kinesis is a powerful data streaming platform designed for ingesting and processing large volumes of real-time data. Although it supports ordering within a shard and can store and retrieve messages, it is generally used for real-time analytics pipelines rather than message queuing between loosely coupled components. It also introduces additional complexity that may not align with the core requirement of simple intercomponent messaging. Incorrect, because it is optimized for streaming data, not standard message queuing between components. Option D, Amazon Simple Queue Service, Amazon SQS. Amazon SQS is a fully managed message queuing service that enables communication between distributed application components. Importantly, SQS provides two types of queues, standard and FIFO. The FIFO queue type guarantees that messages are processed exactly once and in the exact order they are sent. First in, first out, fulfilling the key requirement in the question. SQS also decouples producers and consumers, allowing systems to scale independently and improving fault tolerance. Correct, because it is purpose-built for decoupled messaging with FIFO ordering guarantees. A company is migrating to the AWS cloud and plans to run experimental workloads for 3 to 6 months on AWS. Which pricing model will meet these requirements? Let us identify and interpret key phrases in the question that will help with answering it. This question centers on cost efficiency during a cloud migration phase with experimental workloads that are expected to run for 3 to 6 months. The terms experimental and 3 to 6 months indicate that the workloads are temporary and short-term in nature. Therefore, any pricing model requiring long-term commitment or upfront payment may not be suitable. The right model must allow for flexibility, no long-term lock-in, and cost-effective scaling as needs evolve during experimentation. Option A, use savings plans for a 3-year term. Savings plans provide discounted rates over a 1 or 3-year term in exchange for a commitment to a consistent usage amount. While they offer significant savings, they require long-term financial commitment. This contradicts the scenario's temporary nature and its 3-6-month timeframe, making this option unsuitable. Incorrect, because it requires a 3-year commitment, which doesn't align with the short-term workload. Option B, use dedicated hosts. Dedicated hosts provide physical servers for your exclusive use. They're designed for scenarios involving licensing compliance or highly regulated workloads, not short-term experimental ones. Dedicated hosts are typically more expensive and involve ongoing resource management, which adds unnecessary complexity for temporary projects. Incorrect because it is costly and designed for long-term specialized use cases, not short-term experiments. Option C. Buy reserved instances. Reserved instances offer discounted pricing compared to on-demand instances, but require a commitment of either 1 or 3 years. Even if the usage pattern is predictable, the fixed nature of RI doesn't provide the flexibility needed for experimentation and short-term testing environments. Incorrect because it requires long-term commitment. Not suitable for short-term experimental workloads. Option D. Use on-demand instances. On-demand instances are ideal for workloads that are temporary, unpredictable, or short in duration. Just like the experimental workloads described in the scenario, they allow you to pay for compute capacity by the hour or second without long-term commitments or upfront costs. This provides maximum flexibility and cost control during testing phases, enabling the company to quickly scale up or shut down resources as the experiment evolves or concludes. Incorrect, because it offers the flexibility and no long-term commitment needed for 3 to 6 month experimental workloads. Which actions are examples of a company's effort to right-size its AWS resources to control cloud costs? Choose 2. Let us identify and interpret key phrases in the question that will help with answering it. The key concept in this question is the effort to right-size AWS resources to help control cloud costs. Right-sizing means adjusting resources to better fit the actual workload requirements, eliminating over-provisioning, selecting appropriate services, or scaling based on usage patterns. This typically involves analyzing utilization trends, matching services to workloads, and optimizing configurations for both performance and budget. Importantly, right-sizing is about efficiency, not just redundancy or high availability. Option D. Use multi-AZ deployments for Amazon RDS. Multi-AZ deployments improve availability and disaster recovery, but they duplicate infrastructure across availability zones, often increasing costs. This setup is excellent for fault tolerance but does not align with right-sizing, which focuses on minimizing excess resource allocation to control expenses. Incorrect because it enhances availability, not cost optimization. Does not align with right-sizing goals. Option E. Replace existing Amazon EC2 instances with AWS Elastic Beanstalk. Elastic Beanstalk is a platform as a service that simplifies application deployment and management, but moving to it from EC2 is an architectural shift, not a right-sizing effort. It may lead to better developer productivity or operational efficiency, but doesn't necessarily address resource sizing or cost control in a granular way. Incorrect because it is a modernization move rather than a direct right-sizing action. Option C. Use Amazon S3 lifecycle policies to move objects that users access infrequently to lower cost storage tiers. While this is an effective storage cost optimization technique, it's not typically considered right-sizing. Right-sizing implies adjusting resource size or capacity, whereas lifecycle policies are more about automated tiering based on access frequency. It's a great practice for cost savings, but not directly aligned with the concept of right-sizing. Incorrect because it is a storage tiering strategy to control costs, valuable but not by right-sizing. Option A. Switch from Amazon RDS to Amazon DynamoDB to accommodate NoSQL datasets. This is a strong example of right-sizing by choosing the most cost-efficient service for the data model. If the application only requires a NoSQL database, running a relational database like Amazon RDS may result in unnecessary compute and storage costs. By migrating to DynamoDB, the company can potentially lower costs. Correct because it selects a database service that better fits the data model, improving cost efficiency. Option B. Base the selection of Amazon EC2 instance types on past utilization patterns. This directly reflects a right-sizing principle. By analyzing CPU, memory, and network utilization, the company can identify underutilized or over-provisioned instances and shift to more appropriately sized ones. This reduces wasted resources and can significantly lower EC2 spend while maintaining performance requirements. Correct, because it matches EC2 resources to actual usage, minimizing over-provisioning and excess cost. A company website is experiencing DDoS attacks. Which AWS service can help protect the company website against these attacks? Let us identify and interpret key phrases in the question that will help with answering it. The key challenge in this question is defending a company website from DDoS attacks, distributed denial of service attacks that attempt to overwhelm a target system with an excessive volume of traffic. In the AWS ecosystem, protecting against such network layer and application layer attacks requires services that can absorb traffic surges, filter malicious requests, and respond automatically to abnormal traffic patterns. The question specifically points to a solution that protects websites, which implies a focus on services that integrate with web-facing workloads like Amazon CloudFront or application load balancers. Option A, AWS Resource Access Manager. AWS Resource Access Manager, RAN, is used for sharing AWS resources across accounts or within an organization. It helps with governance and permissions but does not provide any form of network security or DDoS mitigation. It plays no role in traffic analysis or defense against high-volume attacks. Incorrect, because it manages resource sharing, not web security, but relevant to DDoS protection. Option B, AWS Amplify. AWS Amplify is a development platform that helps build and deploy full-stack web and mobile applications, offering hosting, authentication, and back-end services. While Amplify-hosted websites benefit indirectly from AWS's secure infrastructure, Amplify itself does not include any built-in mechanisms for DDoS detection or mitigation. It's a front-end development tool, not a security solution. Incorrect because it today supports app development and deployment, not security enforcement, unsuitable for DDoS defense. Option D, Amazon Guard Duty. Amazon Guard Duty is a threat detection service that continuously monitors for malicious activity and unauthorized behavior. While it can alert administrators to signs of compromise, including some reconnaissance activity related to DDoS, it does not actively block or mitigate DDoS attacks. Incorrect because it detects threats but doesn't actively defend against DDoS, monitoring only. Option C, AWS Shield. AWS Shield is the dedicated AWS service designed to protect against DDoS attacks. It provides two tiers of protection. AWS Shield Standard, which is automatically included at no extra cost and protects against most common and widespread DDoS attacks, and AWS Shield Advanced, which offers more sophisticated protection, including detailed attack diagnostics, cost protection, and access to the AWS DDoS Response Team, DRT. Shield works closely with services like Amazon CloudFront, Route 53, and Elastic Load Balancing to absorb and deflect malicious traffic, making it the right tool for protecting a public-facing website from volumetric and protocol-based attacks. Correct, because it is specifically designed to mitigate DDoS attacks, ideal for protecting web applications. Which AWS service allows users to model and provision AWS resources using common programming languages? Let us identify and interpret key phrases in the question that will help with answering it. This question centers on the ability to model and provision AWS resources, a common task in infrastructure as code, IA practices. What sets the correct answer apart is the explicit mention of using common programming languages to define infrastructure. Traditional IAC tools often rely on declarative templates like YAML or JSON, but newer tools introduce abstraction layers that allow developers to define resources using familiar languages such as Python, TypeScript, Java, or C#. This requirement narrows the field significantly to tools that offer programmability alongside infrastructure provisioning. Option A, AWS CloudFormation. AWS CloudFormation is a core IaaC service that allows users to provision AWS resources using declarative templates, typically written in YAML or JSON. While it's highly capable and widely used, it does not support defining infrastructure directly in general-purpose programming languages like Python or JavaScript. Therefore, it does not meet the specific requirement outlined in the question. Incorrect, because it supports IAC with declarative syntax, not general-purpose programming languages. Option B, AWS Code Pipeline. AWS Code Pipeline is a CI/CD service that automates build, test, and deploy workflows for application updates. While it can invoke provisioning tools as part of a deployment, it is not used to model or define infrastructure itself, and does not provide a framework for defining AWS resources in any language. Incorrect because it manages CI/CD pipelines, not infrastructure modeling, unrelated to. Option D, AWS Systems Manager. AWS Systems Manager provides a unified interface for managing AWS resources and automating operational tasks such as patching, inventory, and runbook execution. While it is excellent for post-provisioning resource management, it does not provision AWS resources via programming languages, nor is it used for modeling infrastructure. Incorrect, because it focuses on management and automation, not infrastructure provisioning via code. Option C, AWS Cloud Development Kit, AWS CDK. AWS Cloud Development Kit, CDK, is the modern infrastructure as code tool from AWS that allows users to define cloud infrastructure using familiar programming languages, including TypeScript, Python, Java, C#, and Go. It synthesizes code into CloudFormation templates under the hood, but gives developers the power of constructs, conditionals, and loops, offering a rich, object-oriented abstraction layer over raw CloudFormation. The CDK significantly enhances developer productivity by integrating infrastructure definitions into standard application development workflows and enabling easier reuse and testing of configurations. Correct, because it is purpose-built or defining infrastructure using general programming languages matches the requirement precisely. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.